right. All right, we're live.
Great.
So, how'd the prep go for everyone? Oh, you can't get on my computer.
I think it really kind of went okay. Biggest thing I think was just learning how to do the computer side of things. Again, with me, it's just using SPSS. But, after it all worked out, so I think just more repetition doing that.
I could go through some of it, but some of it, the statistics or the data portion kept opening up in Chrome. And then when I tried to get on Excel or on SPSS, it would not translate. And I had no clue how to figure it out. Anybody have that problem?
Have you tried using the VMware?
Yeah, well, that's what I was on, was the VMware to do SPSS. But then when I opened up the data for, it was the one for the men that had the heart attack on the soccer fields, that opened up as a Chrome program, but it wouldn't translate over. It was a mess. So I had a couple of them that did that, so I couldn't complete the assignment.
Yeah, sometimes the data is really weird.
Yeah.
The only issue I had was on the homework, like it had you copy and paste the data into the Excel file, right? And then it got me I had the degrees of freedom wrong on one of them. I don't know why. But like the total degrees of freedom was correct, with the individual degrees of freedom of each of the two. I think it was like men and women salaries or something.
Oh, right.
Those were individually wrong, so I don't know if that was a typo on the key or what, because I got it right. I got the last part right, but the steps wrong, so it didn't really make any sense to me.
Was that one of them where they said if they're unequal amounts of people that you'll always use the smaller one? Would that have been why?
I don't know, because like it asked for the degrees of freedom of the women and it asked for the degrees of freedom of the men, and then it asked for the total one.
Right.
So it was like, and I got the one for like the men, I think it was wrong, or the women. The other one was right, and then the total was right. So I don't.
Huh.
It's kind of like it didn't add up, you know.
That is weird. Yeah, I don't know.
I don't know if I just wasn't into this section or what, but I don't feel like I prepared as well, unfortunately.
Well,
It was kind of.
As the technology gets more difficult for me to figure out, I find myself doing that same thing. If I can't get the technology, then I'm like, I can't do it.
I think for me, it was that like about half of it was a review. And I have a hard time when it's like some of it's review, some of it's new, because then it's like the review just like, okay, whatever. And then I kind of zone out and then like, oh crap, I missed something I didn't know, you know? That's kind of like.
Yeah. And I feel this lesson was like that.
Yeah.
Well, just because it was such similar stuff to the last one, except you had unrelated groups. Other than that, it was everything was almost the same.
Yeah, and then the margin of error was different. So, all right. Well, I'm ready to start the quiz if y'all are.
Okay.
Yeah.
Yay, this quiz actually works. So,
Okay.
Give me a second here. I gotta do a couple things.
I was gonna say, is everyone in?
Yeah, I'm in. Just
Yeah.
trying to get my software and everything set up how I want it so that I can move along.
Yep.
Just gotta open a couple things.
Leilani, do you feel like it takes longer to look through it in the SPSS and to get everything plugged in than in the Excel?
I don't know for sure, but I will say I don't think it takes me a long time because I've never done it in Excel, but assuming it's going to be about the same because in Excel, I guess you have to
Yeah.
I
do
really
some
don't
amount
think.
of clicking.
I know some people. I don't know if they really like us using Excel or whatnot, which I think is dumb, personally. But that's my opinion.
Mhm.
I don't know. I don't think it's really a huge difference once you know how to use it. I don't know. Like SPSS, I read the instructions for it, and it's not that hard. Excel is not that hard either. I don't know. Like they're really similar processes.
I feel like the SPSS takes me longer, but then it gives me more information with one thing, where in the Excel I have to change back and forth to different files
Yeah, that's true.
and stuff.
That is true, actually.
That's
SPSS is easier in that
interesting.
sense. In that sense. But Excel, I feel like on my computer, anyways, runs a lot better.
Oh, does it?
Yeah, SPSS gets a little laggy.
Yeah, so far I haven't had any complaints with it, and yeah, once I just memorize and how to navigate, then it actually is quite useful.
Right.
Anyway, are you guys in?
I have mine open.
Yeah, I'm ready. On question 3, what requirements must be checked when conducting a hypothesis test? Comparing two means with independent samples, mark all that apply. Everything but C, right? Simple random sample, it's distributed, and sample size, no, not D, sorry.
Yeah, I put A and B.
A and B.
Yeah.
Yeah.
Now, what did it say to do when your data are different sizes? What were the instructions?
I'm not too sure.
When the,
Well, we'll figure it out when it happens, I guess.
like I'm trying to remember when it's different in, I'm doing Excel and it's different in SPSS. You just open up two separate groups, and
Yeah.
I don't know what you do in Excel though.
You do the same thing as far as I know. You just take the data, put it in there, and voila. I mean, I guess both of them work the same way. All right. So 4 is T-score, right?
Yeah, I put T-score.
5, 2 samples are independent if B.
Yep.
Tells me
Yeah.
nothing.
B.
All right.
Two samples are independent to.
Dentist's office.
All right. Wait, so we need, which ones, does it matter which one's like your group 1 and which one's your group 2? I guess mu 1 would probably be Idaho Falls, right?
Yes, that's how I set it up. But now that you ask the question, I guess if you just keep track.
Well, it's asking if Idaho Falls is less than Rexburg. So I would think that you would put Rexburg as 1.
Well, yeah, but if you look at the alternative hypothesis, it says that Idaho Falls is less than Rexburg, and then it has the mu1 and mu2, and mu1 is on the left-hand side of the equation.
Oh, yeah, it does. No, no, it says, oh, yeah, it does. Yeah. I wasn't reading that top part, that top section, first paragraph.
Yeah, there we go.
So she has degrees of freedom, 37.996.
That's what I got.
I'm still messing with it.
Yeah.
Three decimal places, yeah. And then for standard deviation, 206.637.
For Rex, for number 7, 0.637.
Wait, 0.637 for the standard deviation?
Now I wanted to double check to make sure I put my groups in right.
Hold up 1 second. I'm going to re-invite Francisco. He's calling me on the other line. See if he joins in. Hold up, trying to get Francisco in here. Oh, there he is.
Hey,
Hey, I was just about to send you another link. All right, so what'd you get, Leilani, on 7?
So, I mean, this is all just SPSS, but it's telling me that the standard deviation for Idaho is 208.875, and for Rexburg, 6.637.
That's what I'm getting to, Leilani, 637.
Yeah, that's what I got
Okay.
too. I thought you had said like 16 point something. I was like, what?
what was 7 again?
Oh, okay.
206.3, sorry, 206.637.
Yep.
And so your T-score is going to be, is it plus or minus? Or is it just the negative 0.434?
I have negative 0.434.
I thought I saw something though about it, like it's supposed to be plus or minus. Well, case of if you use it on like a t-distribution graph, but I don't assume we're doing that. So, because like a z-score, you'd always take the negative and positive, but I think it's just 0.434 or negative 0.434.
Yep.
Yeah, that's all I
Negative 0.434.
see.
Negative 0.434, yeah.
Yeah.
And then 9, I got 0.333.
Okay, so tell me how you did. So is this a p-value of just Rexburg? Yep.
No.
Yeah, what I did is just plugged in our T-score to the applet. You guys have a different way of going about doing it. It's just that it doesn't give me a p-value like it does everything else.
Right.
but I mean, it's easy enough to just put in that t-score to the applet, and then you have to, look at your alternative hypothesis, or see what it's asking to see whether you need to do a two-tailed test versus a one-sided.
Yeah, so that's the same thing I got. Excel just does it, but so I did it in the output, like you had said. I got 0.332, which is a little bit
Yeah,
different.
that's what I got.
But then, does it want you to do that? Because that's for like a Z distribution.
I know, and that's where I was curious to see what it would give me and how it would. So I guess that's what I'm asking is also, how do you guys figure it out? Because I'm not sure my way is 100% correct.
Because it,
What's it? Okay.
so you don't use the p-value that just shows up for the one sample?
What are you using, Excel or SPSS?
Well, I'm doing Excel this time, and it shows up as a p-value, but it's not the same thing that you're getting. It's 4.217.
I got the same thing, and I'm using Excel as well.
Oh,
Are you sure you're doing less than? Are you not doing like greater than or something?
well, so you got the same thing?
As the, yeah. Shoot, come on. Seriously.
Okay.
I don't know what you have clicked on.
Yep.
Did you?
So when I change it to less than, it's 0.999.
I think you have something typed in wrong. Are you getting the standard deviation as 208.875 for variable 1 and variable 2 is 206.637?
No, this is just Rexburg, right?
On Excel, make sure you're going to okay, so on the bottom you have different worksheets, right? Make sure to be on a 2-sample t-test. And there it allows you to do, I know, last night I was doing it all by hand, and then I was like, wait a second. And then I clicked on that, and I was like, oh, what a joke. Just laughed. I also did the same thing with the sample t-test. I did it all by hand, and then I figured out that it does it for you. What?
Yeah.
What a joke.
Actually, I just found a shortcut for SPSS. It does give me that two-tailed, which is the p-value of a two-tailed test, and it does say 0.666. So I guess
So
that means that 0.333.
Because it's
So I don't know if it's just coincidence that the applet gave me almost the correct answer.
Well, isn't it like the higher your degrees of freedom, the T distribution approaches the Z distribution? So it's like, it makes sense that it's really close, but it's not quite right because it's using the wrong distribution.
That makes sense, but I guess it is good to practice not doing that all the time and just use this SIG two-tailed number and divide by 2.
The other thing I don't get is, okay, so so it gives you the two-tailed thing, but if you switch to greater than, it's not 0.333 either. I mean, it's different. So I don't get how can the two-tailed thing give you the lower and upper? Because on Excel, so say I just take the same stuff and I switch it to greater than, it's 0.666 is my probability. So like, I don't know how, I just don't understand how it is always right.
Okay, so this time it's the p-value is 0.33327.
Right.
Okay.
But only 3 decimals, so 0.333.
I was just trying to see if I was getting the exact same, if I was doing it right. I am doing it right now.
Yeah. So 10, we failed to reject a null because our alpha was 0.1, so we were above that.
Right.
So if you do not equal to P-value is 0.666.
Oh, did you guys already answer number 11?
I'm doing it now. I'm reading it. Give
I
me
think we're
just a
doing it
second.
now.
Okay.
And this is the same question that I had. A different is what it was last time.
I know, and since you did that, it's gotten me confused because now I'm like double guessing. I'm like, wait, no,
Sorry.
it is talking about. No, I'm not blaming you. It's like good because now I got to really learn it. I'm like, wait a second, what are we talking about? So I think it's B.
Thinking now it's B.
I
Okay,
think
good.
so too. We have insufficient evidence. I think so too.
Because you either have enough evidence or not enough evidence to reject the null. And so we're not rejecting the null, which means that they're not different. I guess like the way to think about it, I don't know, I think if we think about it like null first before we think about like what the actual conclusion is, so we know that we're not rejecting the null. And if you're not rejecting the null, that means you have insufficient.
So what?
So then we automatically know.
So what does the very end mean? That the two cities are different? That the two cities are the same?
Well, that's what we're measuring, like the same or different mean prices for dental care.
But I mean, I know that. But do we have insufficient evidence between the two cities are the same? That doesn't make sense to me.
So I think whenever you're trying to go wrong, what I think of in my mind is which phrasing means disproving the null. And in this instance, disproving the null is trying to say that the two cities are different.
Okay,
I choose that.
that makes sense. Thank you, Leilani.
Yeah.
All right.
Long
Right.
day, Francisco.
Long morning. Yeah, really early morning. Yeah.
Dang it, I think you're going backwards. So I said Colorado is mu1. Yeah, mu1 is Colorado. So just a heads up, everyone.
Wonder if they do that just to trick you.
I think they
Well,
do.
I'm putting it into SPSS right now, and it automatically did it correctly. So I have no idea. But I'm glad you mentioned it so I could double check.
Yeah, because Colorado is the one with fewer, right?
Yeah,
Yeah.
it is.
All right. So I think B would be 12.
B 112.
Yeah, because it would be you're testing to see a different number of times, not more or less. Was it test statistic? -0.845.
Did you guys get negative 0.845?
Yep. And the p-value, I got 0.411. That means you can.
410.
Well,
Round it
yeah, mine's 0.4107.
Yeah.
So I rounded up to 1. Decision do you make? You failed to reject the null, right? What was your level of significance? 0.1, and we're above that, so failed to reject, right?
Yeah.
Yes.
Yeah.
So for the next one, are we supposed to do confidence intervals like it asked us to, or is that paired? Oh no, wait, just kidding. We use we just subtract the means, right? So we get 1 point. What is that? 467.
0.24.
I did that in my head, so I don't know. That would be the difference, and that would be the mean we use for your confidence interval, right? So the margin of error is going to equal Colorado. Is Colorado 1 or is?
Yeah. Colorado's 1.
So 15.2 minus 16 point. Wait a second. No, yes. No, margin of error doesn't even include the mean, does it? I thought margin of error was just the t-score times your standard deviations over this square. No,
I think it's your.
t-score times your t-critical, sorry, not your t-score, times the square root of SD1 over N1.
Root of n.
I don't think it's square root, is it?
The square root of n.
We can't even do that though because we don't have the t-critical value. So are we just supposed to?
Don't you just use the t, the negative 0.845?
No, because that's t, not t-critical. The difference, like z and z score and then z critical.
I know, but
I mean, so it gives us a confidence interval on either Excel or SPSS. And in the previous one, whenever it asked us for the margin of error, all we had to do was take it and go take the high minus the mean, minus the subtraction of the mean. So that's probably the easiest thing to do. I think that's
what I'm doing.
Yeah. That's the only thing that's I think can make any sense. You subtract 16 from 15, right?
yeah.
I know the decimals, I just kind of hollered it out. So did you get 3.681?
I think I'm kind of lost. So what were you doing? What are we doing to find the margin of error?
So-
Were you just subtracting the mean from the upper?
So I
upper
took the
value?
upper of 2.214, right? Is that what you have?
Yeah.
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 And then I subtracted from that the difference of 15.2 and 16.667. But you have to subtract Colorado from, no, sorry, you have to subtract U2 from U1, which means, and U1 is Colorado. Let me make sure I have those values typed in right here. Yeah, Colorado 13 to 19. Yeah. Okay, so you do 15.2 minus 16.67, and that gives you the difference of the means. And then I subtracted that from the upper bound.
Okay, so that's the extra step. I guess I need to go review the notes.
Equals, is it 3.681?
So what I got.
So I guess, is that the rule? And sorry, I didn't do it as thorough a job in the notes. That with these,
I honestly didn't either. That's just how she told me to do it before with the other ones, and so that's what I did on this. But
okay.
So once
it's the
again,
only thing that makes any sense.
sorry,
Yeah.
Colin, to interrupt. You're supposed to
Yeah.
subtract what to get to get the error 95 confidence margin of error.
Mm-hmm.
No, I know what you're supposed to
Yeah.
subtract.
Oh, you take the difference between the means.
Okay.
So you take 15.2 minus 16.667, whatever that difference is, and mine was negative 1.467, and then you take your high confidence interval, 2.214, and you subtract that number, which gives you a double negative, and so you really add it. Did that make sense? Is that what I'm doing?
Yeah.
Yeah. I think so. This confidence interval is kind of interesting. I think what this is actually saying is, y'all correct me if I'm wrong, but it's saying the true difference between the two means is somewhere between -5, or 95% sure it's between -5 and -2.
Right.
And
Which means it could be 0.
so there could be no difference. There could be a positive, one could be more and one could be less. We don't know. And so, okay, that makes a whole lot more sense. Now I finally understood it, I think.
Right. So
Because the information says determine a 95% confidence interval for mu1 minus mu2, which is an estimate for the difference between u1 and u2. So this is an estimate of the difference. And the margin of error is 3.681.
yep.
Okay.
If we did it right, if we got the whole question wrong, we'll go back and redo it.
Yeah, right.
Yeah. So going back to 16, after doing, our step, did you guys get 3.671, was it?
I got 681, Leilani.
Yeah,
What did
I
you
got
get?
681.
Okay.
Did you do it in your calculator?
And then 17 was the negative 5.137.
I got 147.
I got 147. There's your difference. Your 81 versus your 71.
Okay.
Oh my gosh. I just spilled something on myself.
So you guys put what for negative 5 point what?
0.147.
Okay.
Sweet.
And then the upper bound is 2.214.
Yeah.
Yeah.
I don't know why that's a
It may be just because the different software is around.
1/100th. Yeah, because it's just 1/100th off in all of my places.
Yeah, and the next decimal is right. So that's really weird. All right, who wants to be a lucky soul to submit today?
I will go.
Okay.
You got this.
Do you want me to?
Go for it.
Yeah, go right ahead. So what were you guys saying about, so I understand that the 95% means that we're expecting the mean to be between, you know, two intervals. But why would it not be between -5 as the lower and +2.2?
So this is a little different. This is saying the difference is between those, not that the actual mean is.
Okay, well, guys, either I marked them all down wrong or we didn't do real well.
Oh gosh.
So let me read you which ones are wrong. Well, I'll just read them
Okay.
all. 3 is correct, and I had number A and B marked. 4 is correct, and I had the T-score. 5 is correct, and I had B. 6 is correct, and I had 37.996. 7 is correct, and I had 206.637. 8 is correct, and I had -0.434. 9 is correct, and I had 0.333. I'm getting to the incorrect one soon. 10 is correct, and I had failed to reject. 11 is correct, and I had B. We have insufficient evidence. 12 is wrong, and I had A.
Oh, it was B.
B.
My fault? Okay.
Yeah. Do you know why? Because in the thing it says you suspect that freshmen from Utah cooked dinner for themselves in a different number. So it doesn't say less or greater. It says different.
13 I had wrong. And
What'd you have?
I had -8.45.
It should be -0.845.
Oh, point.
According to my thing. I mean, I don't know if I got it right, but
I think I probably just entered it in wrong. 14 I had wrong, and that was probably the same. And I had -0.411.
for 14?
Yeah.
I had just
I had
positive.
Positive.
Yeah, I had 0.411 positive value.
15 I had correct. It's failed to reject. 16 I had correct. It's 3.681. 17 I had correct, and it's -5.147. And 18 was correct, and it's 2.214. So you guys will get them all right. It was just me that had those.
Well, I'll try next.
Well, I'm
I'll
glad
try.
we figured it out, so you could do it too.
Yeah.
Can you explain one more time? I think you almost finished explaining how the margin of error is not between -5 and +2.
Okay. So if you read information, I mean, this is okay. Take it with a grain of salt because I'm also a student, so I don't know that I'm 100% like right on it. But so the information says determine a 95% confidence interval for mu1 minus mu2, which are your two means, right? An estimate for the difference. You could add like which is an estimate for the difference between mu1 and mu2. So in the previous confidence intervals, we've been looking for where do we think the true mean is, and we're 95% confident that it's between this value and this value. This is saying we're 95% confident that the true difference between the dentist bills is somewhere between -5 and 2. So it's not saying that the bill is actually, or no, this isn't talking about bills. Sorry, this is talking about the meals. That the difference between what freshmen do in Colorado and Utah, we're 95% confident that is between -5 and 2, which means that it could be negative or it could be positive, which means you really don't know. So there's no significant difference. Because you have to
what do
remember
mean
that
by
these
it could be negative or positive.
Well, go back and remember that these means we're doing are of the sample, right? And so
Right.
from there, what we try to do is get, okay, so the sample was this, what do we think the real population mean was, right?
Right.
And so that's like an estimate. And so there's always a margin of error because you could be a little off. Like the samples you could have taken, you could have just by happen chance gotten high ones or gotten low ones. And so the confidence interval is basically tells you how confident you are that those are close to the real mean, like the population, or how good of an indicator they are. So since it's between a negative number and a positive number, 0 is somewhere in between there.
Okay.
So in your
I
confidence
see.
interval.
And
so if
rule
it,
that we learned, 0
Yeah, so-
is a possibility. Then
there's no
we
significant
just
difference. Because think about it. So you're basically saying, okay, if it's negative, well, I don't know which it would be, but you could say, okay, variable 1 is always greater than variable 2. Or if it's positive, variable 2 is greater than variable 1. I think I got those backwards. But either way, it could go either way. It could be that variable 1 is greater than variable 2, or variable 2 is greater than 1. You really don't know based off the confidence interval.
Right. Okay. I don't think I was as confused as I thought.
Yeah. Well, and another way to think about it is your p-value, because the probability is high that they're equal to each other. So you didn't reject the null.
Right.
So those two kind of they kind of tell you the same thing.
Equal. Yeah, that's a good point. Okay.
I submitted. I got 100.
Good job.
Yeah. I think it was just a little bit of lack of communication.
Yeah, I'm glad you did submit first, Jolyn, so we were able to all catch it, well, so that you could catch it
Thank you.
and get all the right answers.
Okay.
Cool.
So, did you already turn in or will you turn in the link? Who's going to do the link?
I submitted it on
Yeah.
Tuesday. I can just email it out. If maybe Ben, do you want to submit it?
Sure.
I put your name on the last one, so I don't know if you'll get credit or not. Hopefully you will.
Or you don't get credit if you don't show up.
I don't think so, but I put his name down, so.
And I thought I was gonna be late today, man. Got out.
Did you get those first couple, Francisco?
Yeah. Okay.
Alrighty.
Cool. All right, y'all. Well, I'm going to stop the